Hi, everyone. In order to be able to do anything really interesting with a programming language, you need at least two things. You need conditionals like if statements and switch statements, which we learned at the last lecture. And you also need to be able to loop, to iterate things over and over and over again. So Java gives you several ways to do loops, and so we'll learn those today. The simplest form of loop is called a while loop. And it's a little bit like an if statement, except that the body of the statement isn't executed just once. It's executed over and over and over again as long as the condition remains true. So, to give you a first example, here is code that takes a number n and tests whether n is prime by repeatedly attempting to divide it by every possible divisor. So here's a method called isPrime. It takes in an integer n, and we want it to return a Boolean, true or false, true if n is prime and false if n is not prime. So what I'm going to do is I'm going to try dividing it by every possible divisor less than n. And if I can divide it by any number less than n, then it's not prime. And the first divisor I'm going to try is 2, and then I'm going to try 3, and then 4, and then 5, and then so on. So here's the while loop. The condition I'm going to use is I'm going to keep doing this as long as divisor is less than n, because I want to try out every divisor, every possible divisor that's less than n. And then for each divisor from 2 up to n minus 1, I'm going to test whether n is divisible by that number. And here's where the remainder operation is really useful. I divide n by divisor and I take the remainder. And if the remainder is 0, that means that n is divisible by divisor. And so in that case, I know it's not prime, and so I can return right away. False, it's not prime. Otherwise, so far, we haven't found a divisor yet, so we're just going to increment divisor and try another one. So if it wasn't divisible by 2, let's see if it was divisible by 3. If it wasn't divisible by 3, let's see if it's divisible by 4, and so on. Now, if we make it through the loop all the way, and we try every divisor from 2 up to n minus 1, and none of them are divisible, then we have a prime number. So in that case, we return true. So I want to flag a few pieces of this method. First of all, this little conditional right here, divisor less than n, that has a name. It's called the loop condition. And everything inside the while clause, starting from the first brace and ending with the closing brace here, all of that is called the loop body. And the loop body in the big rectangle is the part that gets iterated over and over again until that condition, divisor less than n, is no longer true. So the way the loop iterates is this. Java walks from the top to bottom, executing things as it goes. When it hits the while statement, it checks whether divisor is less than n, just like an if statement. And if divisor is less than n, it won't execute the loop body even once. And so that's important to know, is that when this method starts, if n is less than or equal to 2, the loop body won't iterate even once. And that's different from some programming languages, like some versions of BASIC, for instance. You might have found that when you write a for loop in BASIC, the loop body always executes at least once, regardless of whether the condition is true or not. But in Java and C, it's different. The loop body won't execute even once if the condition is not true when you start. If the condition is true, then Java executes the entire loop body from top to bottom. And then when it's done executing the loop body, it checks the condition again. It checks again whether divisor is less than n. And if divisor is less than n, then execution jumps back to the top of the loop body and executes the loop body all over again. And then the condition is tested again, and so on. So are there any questions about this? Okay. Then we'll go right on to the next loop. Java has another kind of loop called a for loop. You can think of for loop as basically a convenient shorthand that you can use to write some while loops in a more compact and sometimes more readable way. Now, there's nothing you can do with a for loop that you can't do with a while loop. And so the following two loops are equivalent. You could write a for loop like this. For, you have some initializing statement. Then you have some test that's true or false. And then you have some sort of increment or next statement that tells the loop what to do every time you do a new iteration. And then you have a bunch of statements, which are the loop body, which is what gets executed over and over again. And what this becomes as a for loop is, well, the initialized statement is what gets executed first. Then you do a while loop where you do the test. And if the test is true, then you execute the statements. And when you're done executing the statements, you do the next statement, which is generally an expression that increments some loop variable or decrements some loop variable or something like that. So these two are equivalent. So to give you an example of how to use that, let's come back to our example here and just rewrite it as a for loop. So by convention, although you don't have to do this, the thing that initializes the loop variable, divisor, is usually built right into the for statement. So I'm going to cross that out. I'm going to cross out the while. And I'm going to change that all to a for loop. So there's the thing that gets my loop variable started. Here's the test I'm going to do over and over again to decide whether to re-execute the loop. And every time I finish executing the loop body once, I'm going to increment the loop counter divisor. So now there's the loop condition in the middle. So now you can just look at this one for statement, and you can immediately see that the goal of this statement is to try every value of divisor from 2 up to n minus 1, increasing it 1 each time. And so for is a nice syntax for when you have a sort of simple counter and you just want to count up or count down. So you can just look at that one spot and see exactly what values of divisor the loop is going to roll over. Any questions about that, about for loops? So I want to make an important statement about loop bounds. There's a very common mistake that people who are learning Java or C for the first time make that you should try to avoid. And that's you should always be very conscious of where your loops are going to end. So to give you an example of this, actually I think I'm going to start on a new board here. I'm going to write down a little method whose job is to print all the prime numbers in the range from 2 to n. So let's find all of the prime numbers up to n. And I'll tell you in advance that there's going to be an error in this method, and so you try to see if you can spot the mistake. I is going to be my loop counter. I'm going to write a for statement that goes through all of the values of I from 2 to n. And for each value of I, I'm just going to call that last method I wrote to see if I is prime. And if it is prime, I'm going to print it out. A little space to separate the numbers from each other. And then close off the if, the for, and the is print primes method. So can someone tell me where the mistake is there? Yes?
I is equals n, what to check.
That's right. The problem here is that this is not going to check whether or not n is prime. If n is prime, n is not going to get printed out. And the reason why is that the loop only iterates when I is less than n. It will not do an iteration when I equals n. As soon as I gets incremented to n, it's not going to run through the loop again. So n will never get checked to see if n is prime. So the error is the condition should be I less than or equal to n. That would be correct. So there are sort of two different forms that you'll see very commonly. One is a lot of times you want to count from 0 to n minus 1, but other times you want to count from 1 to n. And so those are particularly common examples of loops, and you need to make sure that you always get your condition correct for whatever it is you want to do. Questions about that? Yeah. Oh, well, in this particular case, print does not put a carriage return at the end of the statement. So what this will do is it'll print all the primes in a row without putting carriage returns between them. And if you want to look at 1,000 primes at once, that's really handy. So now that we've got loops, let's look at something more interesting to loop on. An array is a way of declaring a very large numbered list of variables. Like, let's say that you wanted to write a program that keeps track of 1,000,000 different readings from a thermometer at 1,000,000 different points in time. Do you want to write 1,000,000 lines of code that read the thermometer 1,000,000 times? No, you don't. So what you need is a way to create a numbered list of variables, and then you can just write a little loop that goes through the numbered list of variables and stores a different temperature in each variable. And that's what arrays are for. An array, well, in Java, every array is an object. And it's treated like other objects. But it's a special kind of object because it consists of a numbered list of variables. And each of those variables can be a primitive type or a reference to an object. And we'll see how to define both types eventually. But let's start off with an array of some primitive type, namely characters. So here's the array on the right. The way I generally draw an array is an object that's subdivided into little boxes, and those little boxes are numbered from 0. And the number of boxes can vary. Here I've got 4 boxes, but if you want 1,000,000 boxes, you can have that too. And in this case, I'm demonstrating an array of characters, so you can store a different character in each box. And since this is an object, if you want to be able to use it, you will probably need to have a variable somewhere that references that array. So let's call that C. So that's what an array looks like. Now let's see what kind of code you have to write to make this happen. Well, I got to start with the reference. So let's declare that reference. Here's how you do it. I want an array of characters, so I'm going to start by writing char, but then I'm going to add open square bracket, close square bracket, and that says, well, really I'm declaring an array of characters, not just one character. And so this is going to be a reference type, and I'll name it C. So this is a reference to an array of characters. And in Java, unlike in C, for those of you familiar with C, you don't have to decide yet how many characters that array is going to have. A reference to an array of characters can refer to an array of any length of characters. And if you want to declare an array of ints, then you say int bracket bracket C. So whatever you want an array of, you can get. So now, that gives me a reference, but it doesn't actually give me an object yet. To create the array object, I have to construct it with the new command, just like any other object in Java. So I write C equals new. And then here's where I normally would put the constructor, but arrays have a special syntax. I say new char, open bracket, And then I have to specify the length of the array. Because when you actually create an array object, that object has to have a length. So that creates the array there. And once I've got the array, I can start filling characters into those boxes as I wish, or reading characters out of the boxes. And so store the character B into box 0. And by the way, a little reminder, both of these are apostrophes. So you don't use a left quote and a right quote, it's all right quotes. And I can fill in characters into the existing boxes. I can also try to fill a character into a non-existing box. But if I try to do that, Java will notice when it actually runs the program that the array that C is pointing at doesn't have a character of index 4. So when you try to execute this line of code, this will give you an exception at runtime. Now, that's not a compile time error because at compile time, Java doesn't know how long the array C is going to be when it compiles this line. But at runtime, it finds out, oh, C points to an array of only length 4, so there is no index 4, so I can't store your character, so I'm just going to give you what's called an array index out of bounds exception, and mysterious error message, and quit. Questions?
Can the entries only be primitive types, or can they be
Can what be?
Can the entries be only be primitive types?
Your entries have to be the type that you declared when you declare the variable. So if I'd rather have, say, an array of string types, then I can certainly do that. I can say string bracket bracket s equals new string 8. And that'll give me an array of 8 references to string objects. It won't actually create the string objects, but it'll give me the references. Other questions? Yes?
Can you have other objects instead, other than just, I guess, strings and chars, maybe like dot?
Sure. Any object you want, you can put there instead of string. Yes? Every entry in an array does have a default value. In this case, when you first create the array with this line, every entry in the array is going to have a character of ASCII 0 filled into it. And likewise, if you create an array of ints, the ints are all originally 0, and so forth. Yes? Well, actually, you're allowed to do either one. The question was, do you put the bracket here after the string, or do you put it here after the S? And the answer is you can do either one. Java will accept both of them. Yes?
Is it possible to put more than one type of object in an array, like you can have integers and characters in an array?
Okay, the question is it possible to put more than one type of object in an array? Like, can you have integers and, could you have strings and dogs, for instance? And you certainly can. This will be clearer later on in the semester when we learn about inheritance. But if you create an array of objects, then you can store any kind of object you want in the references in that array. So dogs or strings or whatever. But what you cannot do is you cannot mix a primitive type and an object type in the same array. So I can't have some of these entries containing chars and other ones containing references to objects. Or I can't have some of them containing chars and some of them containing ints. If I either have to pick one primitive type or I have to pick an object type, which could be all objects. Other question? Yes?
Can you have more than one row?
Can you have more than one row? Yeah, we're going to do multidimensional arrays next and see how those work shortly. In the back. So double quotes are for strings, single quotes are for characters. You need to distinguish between characters and strings or Java will get them confused. They're just not the same thing at all. A character is a primitive type. A string can have any number of characters in it, but it's an object. Other questions? All right. Every array has a field that tells you what its length is, assuming the reference actually points to an array object. You can look up the array's length field. So in that case there, the field called c.length tells you the length of the array. But you can never assign a value to that field. You can't change the length of an array by trying to assign something to it. If you were to write, say, c.length equals 7, then that's going to give you a compile time error. Java won't let you change that. So you can read the length of an array whenever you need to know it, but you can't write it or change it. Yes?
If length is a method that you're calling on the object C, why don't you have parens after length?
It is not a method. It is a field. So that's the reason you don't have parens. It really is a field and not a method. Now, strings have a length method, and that is a method and not a field. So that's very confusing. I always have to look up myself whenever I use length. Which one uses the field and which one uses the method? I can never remember. I always have to look it up. But for arrays, it's a field, and for strings, it's a method. Yes? The difference between a method and a field? A method is a piece of code that you call like this. A field is just a variable. It's just a box somewhere in memory that stores some value. Yes?
When you define your own class, can you make some field read only?
When you define your own class, can you make some fields read-only? The answer is no. Java doesn't currently provide a way to do that. It provides a way to put some fields off limits altogether, but it doesn't distinguish between reading and writing. Yes?
So length, in effect, is an instant variable for the object array.
Right. But it is a variable for the object array. Exactly. So now that we know about arrays, we can come up with a faster algorithm for computing primes. So I want to find all the primes between 2 and n and print them out, and I want to do it as fast as possible. So we can do a lot better than what we did over there, which is really slow, because it's testing way too many divisors against every single number to check if it's a prime or not. So we're going to look at a much faster method that dates from ancient Greece and is called the sieve of Eratosthenes. The idea of the sieve of Eratosthenes is that all integers are assumed prime until proven composite, and then we're going to go through a loop, but instead of looping through each number and testing whether it's prime or not, instead we're going to loop through all possible divisors, and for each divisor we're going to wipe out all the numbers that it divides and wipe them off the prime list. And by being clever about it, we can do this where we only test the prime divisors. So let's write a new code. This is called print primes, just like the last print primes, and it does the same thing that the last print primes does, which is prints out all the prime numbers from 2 to n, but it uses a much faster algorithm to do it. So it'll just run a lot faster, especially if n is big. Okay, the first step is I'm going to create an array of Boolean variables called prime. Prime is going to be for each of the numbers. It's going to be true if I think the number might be a prime, but I'm not sure. It's going to be false if I think that that number is for sure not a prime, if I've proven that that number is not prime. So I want to have prime for every number up to n. So I'm going to create a new array of Booleans. Of size n plus 1. Why did I declare an array of size n plus 1? Anybody? Yeah.
Like when you got started to n-1, so
That's exactly right. The answer is when you declare an array of length n, you get indexes from 0 to n minus 1. But I want to have an index for n. So I declare an array of length n plus 1 so that it'll go from 0 to n. So the first thing I'm going to do is I'm going to initialize the whole array to true. So every number from 2 to n, I'm going to assume those numbers are prime until proven otherwise. So we start by assuming they're all prime. Now to continue the method, I'm going to go through every possible divisor that is prime and see if any of these numbers are divisible by that divisor. So I'll start with 2. I'm going to check every single number that's divisible by 2, and I'm going to wipe them off the primes list. And I'm going to keep this loop going for all divisors, all possible divisors, from 2 up to the square root of n. Okay, so what my loop condition here really says is that I want to do all divisors that are less than or equal to the square root of n. And I'm going to leave it as a thinking exercise for you after class to figure out why we can stop at root n. All right, now I want to check every possible divisor, but I only have to check the prime divisors. I don't need to mark off the list every number that's divisible by 6, because those numbers have already been marked off the list because they were divisible by 2. So I only have to do the prime divisors, and that's going to save me a lot of time. But if a divisor is prime, I'm going to go through the list and I'm going to mark off every single number that's divisible by that divisor. So I start with 2 times the divisor, and I keep on going up right up to n if necessary. And each time I iterate this loop, I'm going to go on to the next multiple of divisor. And so I is going to loop over all of the multiples of divisor and scratch each one of them off the list by saying that that's not a prime number. And once those loops are finished, now my Boolean array is going to reflect which numbers are prime and which ones are not. So the last thing I got to do is just very simple. Go through the array one final time and print out all the prime numbers. End of method. Now, I think it's worth your while to take some time to understand this method, and the only sure way to do that is to sit down with a piece of paper after class and pretend that you are the computer, pretend you're the Java virtual machine, and actually walk through this loop for, say, n equal to 10 or some small number, and execute it yourself. And if you don't understand how this code works now, once you actually executed it yourself, you will. Questions about this? Yes?
Is there a way to set, when you're declaring an array, is there a way to set all of the values to a particular value?
There's probably some method hidden deep within the Java library, because it's a huge library. But the way I do it is I write a loop. Other questions? Yes?
Can you have a dynamic array? Like, you have to initialize something like
Java doesn't really have a dynamic array built into it. There are libraries in the Java API that will try to simulate a dynamic array where you can dynamically change the length of the array. Let me add one final thing about this method I've written. You'll notice that I never actually use prime 0 or prime 1. The first two elements of the array, I never look at them or write to them at all. But that's no big deal. You can also have, in Java, multidimensional arrays. So for instance, a two-dimensional array is an array of references to one-dimensional arrays. You can also have a three-dimensional array, which is an array of arrays of arrays. And if you want, you can have a 10-dimensional array, whatever. So here's an example of a two-dimensional array. It's called Pascal's triangle. Some of you might have seen this. The idea is that you draw a little sort of triangle where you have ones down the left side and ones down the right side. And then you fill in the interior values by adding the two numbers overhead. So for instance, we're going to write a number right here, which is the sum of this number and this number. So 1 and 1 is 2. 1 and 2 is 3. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4. 1 and 4 is 5. 4 and 6 is 10. 4 and 1 is 5. And you can keep drawing this triangle all the way down. This triangle, the numbers in this triangle come up a lot in various bits of math. To give you a simple example, the row number I represents the coefficients of the polynomial x plus 1 raised to the power of I. When I say row I, the first row is row 0. So the rows are numbered down from 0. And to give you an example of that, if I write x plus 1 to the 4th power and expand that, that's x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. And lo and behold, the numbers 1, 4, 6, 4, 1 are exactly the numbers we have in row 4 of Pascal's triangle. So that's how that's used. So let's look at some code that actually generates that. So here's a method called Pascal triangle. You feed it an integer n as the parameter, and that tells it how big a triangle to make. We want rows from 0 to n minus 1, basically. Now, the first line of code declares a two-dimensional array called PT, short for Pascal's triangle. And you can see that the syntax for the variable declaration is int, open bracket, close bracket, open bracket, close bracket. But then I want to actually create a new object as well, and that object is going to be an array that has references to arrays of ints. And here's how you allocate such a beast. So new int, open bracket, n. That's how many arrays I want, that's how many references I want to have in my array. Close bracket. And then the second open bracket, close bracket does not have a number in it because those little arrays could be of any length. Then I'm going to write a loop that goes from 0 to n minus 1, one for each row of Pascal's triangle. And for each row, I'm going to set that row of the triangle to be a new array by itself of length I plus 1. So let's see what we've got here. We've got a variable called PT. It points to, let's suppose that n is 5, an array of length 5, and the boxes in that array are all references to other arrays. Then when I go through this for loop here, each time I go through that for loop, I'm going to allocate a new array. And each of those arrays can be of a different length. So the first array has length 1, the second array has length 2, the third array has length 3, and so on. While I'm creating those arrays, I also fill them in. And that's the purpose of this inner loop here, is to actually fill in the numbers into that array. Well, this line of code here and this line of code here, those are the lines of code that fill in all the ones. So this line of code here will put the ones down the left margin. This line of code here puts the ones on the diagonal. And the inner loop here, the job of the inner loop is to fill in all the values in between by adding the appropriate numbers in the column above. So this middle line takes 1 and 1 gives 2, 1 and 2 gives 3, 2 and 1 gives 3, 1 and 3 gives 4, 3 and 3 gives 6, and so on. So again, the best way to understand this code is to sit down after class with a piece of paper and pretend that you are the computer and actually go through and execute this code yourself. Do all the loops, the inner loop and the outer loop yourself, and execute each line just as if you were the Java virtual machine, and see what happens as you execute the instructions and fill in the numbers. Only by this kind of practice, where you pretend you're the computer and walk through a program and actually execute it yourself, will you really get a feeling for how to write code to do things like this when you want to do them. So are there any questions about this? Yes?
Do you have to tell it initially that you are going to have a double array? Or do you just call it a single, one-dimensional array and then later stick arrays in each spot there?
When you declare the original variable pt, you have to tell it that it's going to be a two-dimensional array. And so that's what this declaration does. And you can't, create a one-dimensional array and then promote it to a two-dimensional array later. You've got to make that decision from the start that it's going to be a two-dimensional array. Other questions? Yes?
In line 5, we say PTI is 0 equals 1. How come you're able to get away with assigning the first spot in the reference array without saying how long it's going to be?
Well, the question is, when we execute this line here, how do I get away with specifying that line without having said in advance, without having known in advance how long that line is going to be? And the answer is that this line of code piles it, not worrying about whether that array is going to be the right length or not. Java will figure it out at runtime whether that array is actually long enough for this to be a valid line of code. And then when you're actually running the program, when the Java virtual machine hits this line and executes it, then it actually goes, oh, here's PT. Does PT point to a valid array? Yes, it does. Does that array actually have a reference stored at index I that's a valid pointer to a real array? Yes, it is. So let's follow that pointer and look at the array that it points to. Is that array long enough? Does it actually have an entry numbered 0? Yes, it does. So Java does all of these checks at runtime, and if at any step along the way it turns out that one of those assumptions is wrong, Java just throws an exception and prints a mysterious error message on your screen. Does that answer your question? Okay, so here's your thinking exercises for the weekend. Again, if you really want to understand this code, you should go through these two methods. This method here, the Siva Veritosthenes, and execute them in your head and make sure you really understand why they work and why they do what I claim that they do. See you Monday.